All right, hello there. Today we're going to learn a little bit about some of the patterns that are produced by the transfer of energy within ecosystems, and specifically that would be food chains, food webs, and what you could call food pyramids, or pyramids of different values that we're going to look at. So I found this really cool pumpkin carving that people made last Halloween when we were walking around our neighborhood. And you can see there's sort of a pattern here where one pumpkin is eating another pumpkin, which is eating another pumpkin, and that's more or less the pattern that we're going to use to look at all these relationships between organisms in an ecosystem. So we'll start off with the one that's probably the most familiar with you, the food chain. And a food chain is a diagram that shows the flow of energy from a source to the organism that is being provided with it. So of course the sun is our ultimate source of energy, and so energy comes from the sun and is picked up by this producer here, the grass. And then the grasshopper consumes the energy from the grass by eating it, and so that's why you show the arrow going from the grass to the grasshopper. And then the frog is also a consumer, and it will get energy from the grasshopper, so that's why you show the arrow going that way. And the heron here is also a consumer, and it will get the energy from the frog that it consumes. So all of your food chains will all have the same pattern. The arrow always goes from the organism that has the energy to the one that gets it after it is eaten. So the arrows represent energy flow. Energy flows from the producers to your consumers. Okay, so some terminology that you might not have heard of before, and if you have, great, this will be a refresher. We already are familiar with the green organisms like plants being our producers, and consumers being all the organisms that can't make their own energy. But within a food chain, you can see that there are different levels of consumers. If the organism is the one that gets the energy first from the producer, we call that a primary consumer. And another term you've probably used for that is a herbivore, because they will eat plants or producers exclusively. And then the energy moves on to what you call a secondary consumer. And we call those guys carnivores. And finally, the energy will move on to a tertiary consumer, or maybe further if the case may be. And that could be another type of carnivore, sometimes called a top carnivore, if there's nothing else that's eating that organism. Okay, another way of representing the flow of energy in an ecosystem is called a food web. And as you can see here, it looks quite a bit more complicated than a food chain. But you can kind of think of it as a combination of food chains. Of course, in any ecosystem, an organism doesn't just eat one thing. They often have multiple sources of nutrition and energy. And so a food web is just a little more accurate, showing a greater variety of ways in which the energy can flow through an ecosystem. And so you can see that energy still starts by being picked up from your producers down here, the algae and the clover and the grass, and then flows to your herbivores and then your carnivores. But with a food web, you can also see that there are organisms that consume more than one type of creature. So you got a consumer here that's a beetle, and you got a grass here that's a producer, right? So if you have an organism that will eat both, like this turtle, that means that your turtle is then considered to be an omnivore, right? Organisms that eat more than one thing. Same with this fish here, right? You see the fish consumes some algae, but it also eats some bugs when it can, and that makes the fish an omnivore as well. So with the food web, you can identify omnivores. Now, when you arrange your food chain and you look for patterns of quantity, then size of the population, the mass of the population, or the amount of energy that they have, you often get this decreasing pattern that kind of looks like a pyramid. And so if you start at the level of producers, we call that the first trophic level because that is the basis of the food chain, and that's where all the energy has to start. And then as you go along the food chain, the general pattern for most factors is to decrease. And so as you pass through, you'll see that there'll be less of the quantity at the second trophic level, and then even less at the third trophic level, and decreases more and more as you go up along the food chain and up the pyramid. So let's look at a couple different patterns that follow this general trend. The first one is pyramid of numbers. So if you just counted the number of population, I'm not sure why they call it pyramid of numbers because it's all numbers. But this is talking about the quantity of organisms in a population. So if you took all the blades of grass and you added them up, you might have in a given area, say, who knows, let's say 100,000 blades of grass or pieces of grass. And then if you counted the number of grasshoppers, you'd expect there to be less than the number of blades of grass. And so maybe you have 10,000 grasshoppers living in this area. And then as you go up the food chain some more, you'd expect there to be fewer frogs and then fewer herons. This might be a bit of exaggeration. I've never seen 100 herons in an area ever. But you see the general pattern would be there. You get decreasing populations as you go up the food chain. Okay, so of course this doesn't always work out. There are several places where you can figure out exceptions to this pyramid of numbers pattern. One would be in a forest. In a forest you have trees, but definitely fewer trees than you have bugs. And so it doesn't follow the pyramid pattern. The reason why there's so many more bugs than there are trees is because the trees are really, really big. And so having a few trees is plenty of organism to feed all these insects. And then of course you get a decrease again when you went from the bugs to the woodpeckers, and you get back to your pyramid pattern. Another one here, which again has to do with size, is say you got lots of grass and you're feeding this nice bunny who likes eating grass, nibble, nibble. And of course there's going to be less bunnies than there are grass. But on this bunny, you can have lots and lots of little bugs like fleas. And that's because compared to the flea, the rabbit is huge, again, just like the oak tree. And so this can kind of mess up your pyramid pattern. So there are some places where you don't get a pyramid pattern, but the general trend is usually decreasing as you go up a food chain. Another one here is biomass. So sometimes it's easier for ecologists to study the mass of organisms rather than the size of their population. And so you can project based on some observations that you can collect what the mass might be for all the organisms of a given type. And it again follows this general pattern of decreasing. So easy way to do this is just knock off a zero every time, right? So you go from, let's say, kilograms this time, place with 10,000 kilograms of, 100,000 kilograms of grass, might have 10,000 kilograms of grasshoppers, and maybe 1,000 kilograms of frogs. It's a lot of frogs. And then maybe 100 kilograms of herons. And so you might be able to see the pattern that way with the weight rather than with the number of organisms in the population. Okay, so our last pyramid is the pyramid of energy. Of course, energy is used by all living things to carry out all their life's processes. So that means that no matter what, this pathway is always going to, the quantity of energy is always going to decrease. It's roughly 90% each time, just like our estimate before. And so that means that producers will use about 90% of the energy that they absorb. And then 10% gets passed on to the next level. And then the herbivores will use up about 90% of that energy. And only 10% gets passed on to the next level, and so forth. Each organism using up a massive quantity, the majority of the energy that they ingest, and only a small amount gets passed on to the next level. So that is always going to be decreased, and you're always going to get that nice pyramid pattern. And you can make rough estimates as to how much energy is available for each level, just based on starting quantities. Energy, if you're unaware, is measured in a unit called joules. And so let's look at an example. All right, so here we have our good old food chain, and we're given the parameter that 200,000 joules of energy is absorbed by the grass. So the grass has 200,000 joules that absorbed from the sun and turned into glucose. So as the grass grows and lives and does all the things that grass does, it's going to use up 90% of that. And only 10% will get passed on to this grasshopper, which would be 20,000 joules. And then the grasshopper is going to use up 90% of that. And only about 2,000 joules is going to get passed on to this frog. And then the frog is going to use 90% of that. And only about 200 joules gets passed on to the heron. And the heron will use about 90% of that. And whatever's left, decomposers will take care of. So that's the basic pattern for the pyramid of energy. And it is all due to this loss of energy, whereby the energy that's used by an organism cannot be reused by others, ends up radiating off into space, generally as heat. And since it came from space via the sun, it's kind of fitting it ends up there again.